Hello, I'm Liam Crilly. I work on the Unit team, and I'm here to talk to you about an NGINX Open Source project called Unit. But before I do, let me first set the scene by talking about some of the innovations in NGINX. This is Igor Sysoyev, the original author and founder of NGINX, and back at the turn of the century, he was working as a systems administrator, these days probably a site reliability engineer, for a web company, and he was looking after the web servers. And this is at a time when the internet was going through its first phase of explosive growth, and the web servers of the day were really just not able to handle the amount of concurrent traffic that they were experiencing. Igor was struggling with this. He tried a couple of things to fix it, and eventually he decided that he needed to build a new tool. He built NGINX to solve the problem, specifically to allow for at least 10,000 concurrent connections on a single web server. But how do you do it? My favorite analogy for this is that being a web server is a lot like playing a game of chess with a large number and often very random opponents. So a client arrives, wants a web page, demands to play chess. The server accepts, makes its move, responds, and the client then might make some more moves, ask for more web pages or not. And we don't know. And if the client's using HTTP2, for example, it might make a bunch of moves all at the same time. We have to figure out what to do with each one of them. But the client might not play exactly by the rules. We have to make the best of what we're presented with and either reject the request or take care of it somehow. And the client might be finished, but probably won't tell us that it's finished. And we're kind of waiting, hanging around, trying to see if it's going to make another move or not. The client might not even be playing chess with us. Might be playing with someone else, with us as a proxy in the middle, in which we have to interpret not only the client, but the responses coming back from the other party. And usually the other party is worse at chess than us, and usually plays very slowly. Because most of the time spent playing chess is waiting. And this is how web servers used to play chess. They have the board, the rules of the game, the pieces, and every time a new client comes up and wants to ask for a web page, we make a copy of ourselves and take care of that client with a copy of our web server program. And as more clients come along, we create more and more copies of ourselves. And this is why we don't scale. This is very fast because we're dedicating an entire process, an entire program to just one client. But if most of the time is spent waiting, we're tying up a load of resources, specifically memory, but also other system resources, because we've got the same copy of the program duplicated thousands of times. It won't get us to 10,000 connections, that's for sure. So what Igor did, and how NGINX plays chess, is that it has the pieces, it has the rules of the game, but it sets out the boards in a room, like in a large playing space. And it allows a client to come up and use one of those boards, and NGINX will play chess with it. But it doesn't wait. When something happens, NGINX takes care of it. There's a new piece of memory to be looked at, a new piece of file from a disk, a new piece of data from the network. Then Unit responds, NGINX responds. It takes care of that, and it moves around, and it keeps going, and it serves a great number of connections. It can serve more than 10,000. NGINX can serve hundreds of thousands of connections on a single server, like a grandmaster playing a simultaneous chess tournament. This asynchronous event loop that allows NGINX to have one process actually scales with CPUs. So we can have one of these event loops, one of these playing rooms being a web server for each CPU core that we have. This allows us to scale connections way further and very efficiently. And so the innovations that NGINX brought to web servers was the asynchronous event loop, so that we can do more with less. A multi-process architecture where we have one event loop per process, which gives us near linear CPU scaling. Double number of CPUs, pretty much double the number of connections throughput that NGINX can handle. And configuration can be reloaded without interruption, without downtime. So if we want to make a new configuration, we create a new set of worker processes with a new configuration and let the old workers handle the existing games until they're finished. This allowed NGINX to become not only the most popular web server on the planet, overtaking Apache in 2019, it remains the most popular web server today, But if you look at the busiest sites with the highest traffic, that have the biggest performance requirements, and the most efficiency, the busiest 10,000 websites on the internet, 44% of them use NGINX. And it was during the kind of middle of this timeline that Unit was born. Igor had been experimenting with some other ideas for a potential version 2 project, just some thoughts of how to evolve the architecture. But we also, with the increasing amount of dynamic content and web applications, wanted to bring that application code closer to the web server, to natively run application code. Usually for PHP or Python, Ruby applications, for example, we have a separate process manager. And NGINX passes processing to that process manager. It's another moving part, and it's often a bottleneck. And so what happened, genesis of Unit, was to combine these two ideas, some of the evolved architecture and this application runtime idea. And the first prototype of that arrived in summer of 2016. The next year, we announced Unit at the NGINX conference, and the year after that, version 1 was available. And in NGINX terms, version 1 is GA, production grade, put it in front of the internet. And we call it the Universal Web App Server. It's an open source project from the original NGINX team. And technically, it has 3 different functions. We call them actions. You can serve static assets. It's a web server. You can natively run application code, and we're reverse proxy. And the vision for Unit is to take these 3 capabilities and make Unit a common universal building block, building, deploying web applications. Because we have these different functions that play at different layers in the stack, and because you can layer one unit with another unit and multiple applications can be running on a Unit server, we can deliver complete web applications with fewer moving parts, fewer pieces, less complexity. And when we do that, we also get the benefits of homogeneity. Same configuration style, and the same behavior, consistent experience, not only in configuration, but at the runtime. And there are also some design goals that went into Unit, some of the evolved architecture that Igor had been working on. Firstly, to not invent a new configuration syntax or configuration language, but to use a standard that already exists. Secondly, that reconfiguration should happen immediately and in situ, in process, without creating copies of itself, and of course, without any downtime or interruption. And finally, to decouple the network configuration from the routing at the HTTP level, from the action that takes place. And so how Unit plays chess and the evolved architecture that we have is that we have our main process that deals with starting things up and tearing things down, the controller process that handles the configuration changes and applies them. And it applies them to the router process. There's just one router process this time, but it's multi-threaded, and that's how we scale. And because of this multi-threading, allows us to apply configuration changes immediately to an existing process. And the router process is where our familiar asynchronous event loop lives. But that's not all, because Unit plays more than chess. Unit runs application code. And so we also have our application processes under the control of Unit. So we might be serving static content, but we might, in this example, have a Python application, PHP application. And Unit can run applications in multiple languages, 7 today, 3 are in progress, and we support a large number of web and API frameworks that you see here. There's detailed documentation for all of these on our website. The biggest difference most people notice when they start using Unit is that the configuration experience is completely different. For example, it's all in JSON. I will take a moment to show you a few examples. Here's my terminal, and let's start by starting Unit. So I'm going to start the Unit daemon, and in fact, I'm going to keep it attached to the terminal so that I can send the logs to the console. And for convenience, I'm going to control and configure Unit on port 8080. By default, Unit would use a Unix socket. So let me put that into the background, and Unit has started. We've got some language modules available, and our processes. We have the main process. We started the controller process for configuration and the router process. And if I look at the configuration, which I have put on port 8080, config, we have an empty JSON object. So let's make it do something. We'll create a file to hold our JSON configuration, and I'm going to listen on a port. One of the cool things about NGINX unit configuration is that it spans both from layer 4 right up to the runtime in a single configuration object. So we can really control the entire application behavior in one place. So I'm going to have a listener. I'm going to listen on all of my interfaces on port 9000. And what I'd like Unit to do with any connections that arrive on 9000 is pass them to the router. There. Let's apply that configuration. So there's the file. Now I'm going to send that to my configuration port. I'm going to use the put method for applying configuration, and I'm going to read the configuration from standard input from the file, and I'm going to send it to port 8080 to the config URI. But that didn't work because I'm trying to pass to the router and there are no routes. So let's fix that. Let's have a route, and let's get that here. Routes are numerous, so it's an array, and the first route I'm going to create is basically my default. What to do if something lands here, and my action is going to be, and I'm going to share my hello world web page, which I'm going to put in my demo directory, in the HTML folder, and I'll pass whatever URI gets sent into that folder. Let's apply that configuration, and it's done. And so now I go to port 9000. I created a unit listener on. I have the simple hello world web page served by NGINX Unit. But Unit's more than a web server. It can also run application code. And I have some application code. I've got the world's most ridiculous web-based microservice. It's called add. It's written in Python, and it takes an array of numbers and adds them together. Not very sensible, but it's good for a demo. So here we are. Here's my web application. It reads the content length from the header, and then it knows how much to read from the request body, and then it converts that into a JSON object. We prepare the result, initialize to 0, and then we iterate over every member of the operands array, and we add them all together into my response result object. And then we send that back, we serialize that object back as text. Pretty simple Python application. So let's make Unit run this application. First of all, I'm going to need, a new route. Let's do that. And this time, I'm going to explicitly match. What am I going to match on? I could match on a number of different things. Here, I'm going to match on URI that needs to be exactly add. I might put a star in here. I might have a regular expression. I might not match on URI. I can match on any part of the request, whether it's a query parameter, the client IP address, the HTTP method, cookies, headers, anything that I can grab from the request, I can add to one of the elements that I want to match my route on. So it's extremely flexible, but I'm going to try and keep this moderately simple. So when I do have a request that matches /add, my action will be to pass that to my add application, which I need to define. So after my routes, I can have applications, and this is just an array, a list of objects. So I've only got one, but Unit can run multiple applications. And so my add application is, as we saw, Python. I need to say where it is. There's the path. Again, it's next to my HTML. The demo directory. And finally, the Python module saw was called add. So save that, and let's apply the configuration. Bring that up to the top. There it is. Reconfiguration is done. Notice I've got some log output. Unit has created a prototype for my application, which helps it create new application processes a lot more quickly, more reliably. And if I look at my process list, I now have these two additional processes. So let's test the application. As you recall, it wanted a JSON object. It's a JSON REST API of an array of numbers. So let's add 1 and 2 and 3 and 500 together. Let me just check that that's good JSON. Yes, it is. And now let's send that to port 9000. So I'm going to read that request body from standard input, and I'm going to send it to port 9000/add, which is where I want it to run. And straight away, there's our response. 1 and 2 and 3 and 500 is 506. Unit is running both. Being a web server, still sending my Hello World web page, and it's running my application code, and there's nothing else running. All I have are the unit processes that it controls. So let's take a look at the configuration again. So that's on port 8080/config. That's everything that I supplied from my file. And I've been updating Unit's configuration in its entirety. And Unit's clever enough to know what's changed, what's new, and it only applies the differences. But I can also apply specific changes. I can navigate this JSON object, so I can go to the routes. And if an object is an array, I can reference it by index. And I can go deeper. I can go, what's the match object? What's the URI key? And if I want to change that value, because I'm a mathematics purist and I think it should be sum instead of add, then I can say it should be sum. And I can put that to the URI, to this precise URI, and I can reconfigure Unit. And if I try and make a request again, where are my operands? There they are. That doesn't work anymore. But now the routes responds to sum. And of course, this extremely dynamic configuration experience also makes Unit extremely easy to automate with deployment pipelines and real-time changes that can affect just part or all of the running configuration. So why should you use Unit? Well, we're all about building and deploying applications. So with Unit, you can build very simple or very complex applications with fewer moving parts, less complexity. So you can build cloud-native microservices, as you just saw, or you can take existing Java monoliths and run them on Unit. Give them a cloud-native configuration. Give them a container-friendly footprint with fewer moving parts and a smaller memory space. And Unit's also suitable for production use. It has high performance profile, it's extremely reliable, especially under stress, high load, and it's well suited to secure runtime environments. Unit has TLS support, which means that you can run true end-to-end TLS, any of the application languages that we support, configured through the same API that I showed you, and where the decrypt, the plain text, only moves across Unit memory space. There's no plain text across network interfaces. There's no plain text across sockets. It moves across memory to memory in process. And we also support application isolation because Unit supports multiple applications. We use Linux namespaces and C groups to protect applications from another and from the host that they're running on. So I'd encourage you to get started with Unit. You'll find everything you need on our website at unit.nginx.org. You'll find the code and our GitHub issues. We're really responsive to issues at our GitHub repo, mailing list, and community Slack is also where you can get some help. So I hope you check it out and look forward to hearing about your experiences. With that, thanks for your time.